Hello guys, this is Teacher Jofi of Southville 8B Senior High School. Our topic today is solving problems involving correlation analysis. For our objectives, after going through this lesson, you are expected to, number 1, compute the Pearson sample correlation coefficient R, 2, interpret the strength of correlation between two variables based on the computed correlation coefficient, and number 3, solve real-life problems using Pearson sample correlation coefficient.
In our previous lesson video, we have calculated the Pearson sample correlation coefficient, or what we call the Pearson R. This correlation is used to determine the existence, strength, and direction of relationship between two variables. Correlation coefficient R is a number between -1 and 1, and written as -1 is less than or equal to R, and R is less than or equal to 1, which describes both the strength and direction of correlation. We have here our correlation scale. We have the R values between -1 and 1, and you should not see values of R greater than 1 and R less than -1 here. For our interpretation purposes, we have here the indicators. At -1, we have a perfect negative correlation here. Okay. For the range between -1 and -0.5, or what we call -0.5, okay, we have a strong negative correlation. For any values of R that lie between -1 and -0.5, these are what we call strong negative correlations. Like for example, if we have -0.75 here, it's a strong negative correlation. If we have -0.6, so it's somewhere here, so we have strong negative correlation. Okay, for the range between -0.5 and 0, we have a weak negative correlation. If R is equal to 0 here, we have no correlation. That means there is no relationship between the independent variable and the dependent variable. If R is between 0 and 0.5 here, we have a weak positive correlation. And for the last range, if we have the R equals 0.5 up to 1, we have a strong positive correlation. And for R is equal to 1, we have a perfect positive correlation. Now, I'd like to remind you guys that this correlation scale is used for our discussions for this lesson, okay? There are other correlation scales in some textbooks which may be using different terminologies and different ranges. But we will use this scale for the purposes of our discussion and interpretations in this lesson. Now let us consider this illustration. Identify the strength of correlation in each value of R. So we are given a value for R and we are going to identify the strength of correlation. Let's look at the first value. We have R equals -1. So going back or recalling our correlation scale, -1 represents a perfect negative correlation. Okay, let's look at the second one. R equals 0.35. So is it a positive or negative correlation? So as you see here, it is positive. Okay, and is it a strong or weak correlation? So let's consider the range wherein this value of R is located. So 0.35 is located in the range between 0 and 0.5. And this is considered a, weak positive correlation. Let's have another one. R equals 0.9. Again, this is positive, okay? So is it strong or weak? That's the next question. So considering the range wherein 0.9 is located, this is in the range between 0.5 and 1. And this is, this is strong positive correlation. Okay, let's consider the next value for R. This is 0.88 or negative. Negative 0.88. So again, this is a negative. Okay, and is it a strong correlation or a weak correlation? So negative 0.88 lies in the interval negative 1 and negative 0.5. Okay, so that's between negative 1 and negative 0.5. And this is, yes, this is a strong negative correlation. Now, let's have the next one, negative 0.49. So, again, we have a negative correlation. Is it strong or weak? So, considering the range, we have negative 0.49 located between the range negative 0.5 to 0. Okay, this is, yes, this is weak negative correlation. And finally, we have 1. R is equal to 1. So, if we have a 1, this is what we call a perfect correlation. So, positive 1 here is a perfect positive correlation.
Okay, let's proceed to the second illustration. Looking at scatter points. So if you remember scatter points, we will look at this for this illustration. We had to look at this notes. Okay, number one, or the first one, trend line is increasing means that there is positive correlation. So if you remember, if you have a scatter points, we are going to find the trend line. Okay, and if the trend line is increasing, that means there is a positive correlation. If the trend line is decreasing, that is a negative correlation. Now, the closeness of the points around the trend line determines the strength of the correlation. The closer the points to the trend line, the stronger the correlation to the variables. So, depende po yan kung malalayo po sila sa trend line, ibig sabihin there's a weak correlation. Kung malalapit po sila doon sa trend line, that is a strong correlation. Let us look at these scatter points. Okay, so we have the scattered points here. Okay, and we have this trend line. As you notice, is this increasing or decreasing? Okay, it is increasing because from this point in the left side, it goes to the right and it goes upward. So, ganyan po ang itsura ng increasing. At kapag increasing, it's positive. Now, let's look at the points. Are they scattered? Malayo ba sila doon sa trend line or malapit lang? So, if you could notice, medyo malalapit lang naman sila. Unlike iba, nandito yung, kung nandyan, sobrang malalayo. So, yan, kapag sobrang malalayo, it's a weak correlation. Since this one, some are very close here, okay? Malapit lang naman sila. So, we can say that this one is strong positive correlation. Okay? Now, let's look at a second scatter point. Okay, we have this example here. Okay, we have the trend line here. This is the trend line. Okay, as you notice, from left, it goes downward as it goes to the right. Okay, so this is decreasing. Okay, it goes down. Pag galing ka dyan sa kaliwa, pababa po dyan, or papuntang kanan, pababa siya. So that is decreasing. Okay, therefore, kapag decreasing, we can say it's negative correlation. Now, let's look at the points here. Ayan. So, compare mo po dito sa trend line. Meron pong napakalapit dyan. Meron namang malalapit. But as you notice, meron malalayo na po doon. Okay? So, malayo na po iyan. Okay? Mas marami po yung malalayo. Okay? Therefore, we can say that this is weak negative correlation. Okay? I hope that is clear, no? Pag nakascatter po sila na malayo sa trend line, that is a weak correlation. Okay? Let's look at our next illustration here. We are given some situations and are going to interpret this. In a survey, the correlation coefficient R between allowance or baon and spending of students was found to be 0.46. Okay? Our R here is 0.46. Now, let's try to analyze this. Is it positive or negative? Okay, so you can see it's positive. Now, is it a strong positive or is it a weak positive correlation? So if it's between 0 and zero point 0.5, it's a weak positive correlation. When it's between 0.5 until 1 or 0.5 to 1, we have a strong positive correlation. Since this one is less than 0.5, okay, we can say that this is weak positive correlation. Therefore, we interpret this as there is a weak positive correlation between allowance or baon and spending of students. Let us look at situation number 2. A study shows that the correlation coefficient R between the temperature and the number of cups of hot coffee salt is negative 0.75. Okay, so take note, your R here is negative 0.75. Okay, so as you notice, it's negative. Now the question is it a strong negative or it's a weak negative correlation? Okay, since it's between 0.5 and negative 0.5 and negative 1, okay, negative 0.75, negative 0.75 lies between negative 0.5 and negative 1. This is a strong negative correlation. Therefore, for our interpretation, we can say that there is a strong negative correlation between temperature and the number of cups of hot coffee sold. Okay, let's have one more of that. Situation number 3. In our previous lesson video, that is module 18 or lesson 18, we have calculated the correlation coefficient R between the number of hours spent in studying and the student's scores in a test as 0.96. In other words, the R we have calculated was 0.96. Okay, how are we going to interpret this? Okay, this is a positive correlation. Now, is it a strong correlation or a weak correlation? Since 0.96 is just a bit less than 1, okay? It lies between 0.5 and 1, but this is very close to 1. Therefore, it is a strong positive correlation. So we can say that there is a strong positive correlation between the number of hours spent in studying and the student's scores in a test. Okay, let us consider this example. Calculate the Pearson sample correlation coefficient. After obtaining Pearson's R, analyze and interpret the results. The table shows data obtained from 6 students in a study about the number of hours a student exercises each week and the score he or she gets in a test. So here's the table. Let us look at this in a while. Okay, we have here the students and then the number of hours represented by X and the score in a test, the dependent variable Y. Okay, student A exercised for 1 hour in a week and he scored 25 in the test. Student B exercised for 2 hours and he scored 5. Student C exercised 3 hours in a week and he scored 20. Student D exercised for 4 hours and then in that week and the student scored 40. Okay. Student E spent 5 hours exercising for a week and then he or she scored 25. And the last student F exercised for 6 hours and he scored 9. So let us look at the steps that we have. Recall the steps that we had discussed earlier. Prior to this lesson video, we had calculated Pearson R and we followed these steps. Okay, so we will follow these steps. Now, the first step is construct a table. So we have here the table, okay? It has X and Y columns. So we copied the values here for X and Y, okay? And then we have a column for X, Y. This is the product of X and Y. X squared, the square of the X values here. And Y squared, which is the square of the Y values, okay? And then we will complete the table as step 2. We complete the table. So we start with XY column, okay? For the XY column, we multiply entries in the X and Y column. Okay, so we multiply that. Okay, look at this. 1 times 25 is 25. 2 times 5 is 10. 3 times 20 is 60. 4 times 40 is 160. 5 times 25 is 125. 6 times 9, 54. Okay, and then let us look at X squared column here. Square the entries in the X column. Okay, so this is the X column here. We will square these entries. Okay, when you say square, we multiply it, each entry by itself. So we have here 1 squared or 1 times 1, 1. 2 squared or 2 times 2, 4. 3 squared or 3 times 3, we have 9. 4 squared or 4 times 4, 16. 5 squared or 5 times 5, 25. And 6 squared or 6 times 6, 36. Okay, so there you go, X squared columns. Now we have Y squared column. Square all the entries in the Y column. So this is the Y column. We square all the entries here. So 25 squared or 25 times 25, that is 625. 5 squared, 5 times 5, that is 25. 20 squared, or that is 20 times 20, you have 400. 40 squared, or that is 40 times 40, that is 1600. 25 squared, again it's 625, and 9 squared or 9 times 9, it is 81. Okay, and then for step 3 here, get the sum of the entries per column. So we have here summation of X, summation of Y. So we read this is read as summation. So summation there, summation of XY, summation of X squared, and summation of Y squared. So to get the values for this, the sum of the entries, so we have to add them because it's called summation, so we get the sum. Okay, so 1 plus 2 plus 3 plus 4 plus 5 plus 6, that gives us 21. Next column for Y column, so we have 25 plus 5 plus 20 plus 40 plus 25 plus 9, that gives us 124. For the next column XY, we have 25 plus 10 plus 60 plus 160 plus 125 plus 54. We have 434. For the X squared column, we have 1 plus 4 plus 9 plus 16 plus 25 plus 36. We have 91. And for the last column, the Y squared column, we have 625 plus 25 plus 400 plus 1600 plus 625 plus 81. We have 3,356. Okay, and we take note that N is equal to 6 because there are 6 pairs here. Okay, there are 6 pairs of entries. This is the first pair, second pair, third pair, fourth pair, fifth pair, and sixth pair of entries. Okay, or we have 6 number of cases. Okay, so let's proceed to the computation of R. So step 4, substitute the values obtained in step 3 in the formula for R and solve for R using our calculator. So copying the values we had from step 3, we have N equals 6, summation of X equals 21, summation of Y is 124, summation of XY 434, summation of X squared 91, and summation of Y squared equals 3,356. Okay, and recalling our formula, okay, we have this formula here. R is equal to N times summation of XY minus summation of X times summation of Y, all over the square root of the product of N times the summation of X squared minus the square of X squared, and N times the summation of Y squared minus the square of Y squared. Okay, again, please do not be confused by this formula. We just have to substitute the values that we have here. Okay, so now we start substituting. Okay, so for N, that is 6, N 6, summation of XY 434 there. Okay. Summation of x, that's 21 here. And summation of y, we have 124 here. Okay. And then all over the square root of 6 for n, and then square root of x squared, that is 91. So we put 91 here. And then square root of, the square of x. So we have here 21, and then we square it. And then again we have n, it is 6. The summation of y squared, 3,356 here. And then the summation of y squared. So summation of y is 124 from this. Okay, and then we square. Applying the mathematical operations, we have 6 times 434, 2,604, minus 21 times 124 is 2,604. All over, okay, we have 6 times 91, 546. 21 squared is 441. We copy the sign there. And then 6 times 3,356, 20,136, minus 124 squared, that's 15,356. Okay, if you notice, if we apply our operations here, this becomes 0 already. So 0, and then we have here the values in the denominator, 546 minus 441, 105, and 20,136 minus 15,356 is 4,760. Okay, since we already have 0 in the numerator, that brings everything to be 0. And therefore, we have r is equal to 0. Do you remember in our scale what is the equivalent when r is equal to 0, or what is the interpretation of r equals 0? Yes, I guess you remember, but if r is equal to 0, we have no correlation. Therefore, for our conclusion, the value of r is 0. Therefore, we can say that there is no correlation between hours spent in exercising and the student's scores in a test. Okay, so there you got it. I hope you learned something today from our discussion. Enjoy and endure, my dear students. Take time to enjoy the good times and the courage to endure our current challenges. Later on, you will reap the fruit of your labor. This is Teacher Goffin saying, God bless you. This lesson video is created based on the Department